Hola, buenas tardes. Yo me hablo Sebastien Stormacq y yo soy un tech evangelist en AWS en Francia. Pero yo no hablo español, so I will switch to English. So you will suffer my French accent in English instead of suffering my French accent in Spanish for these next 45 minutes. So welcome, thank you for being here. It's one of the most difficult time slot of the day because you are all digesting from your lunch, and we all have a natural tendency to sleep a bit after lunch, so I'll try to keep you awake. I have a couple of demo and hands-on, so we are going to build an application together in the next 45 minutes. I'm going to talk about how you can simplify the front-end application, how you can simplify web application or mobile application. My demo will be about web application, but you can do exactly the same with mobile application, actually. And see how you can integrate backend services for user authentication, for API, for storage, for hosting, with your front-end extremely easily, with just a couple of command lines, just a couple of lines of code, and how the backend world and the front-end world are fitting together. So if you are a front-end developer, what's the typical day in your life? The typical day in your life is having your Scrum Master, your project manager coming to you, knocking on your shoulder, saying, hey guy, we have that brilliant idea and we need that new feature. By the way, we need it for in a couple of days. We don't have any more budget. You are by yourself. And of course, if that feature is successful, it has to scale. It has to have all the ET, scalability, availability. It has to have high security. Can you do that? And typically, this is the moment in your professional life when you want to resign, you want to go to a beach, sell cocktail for the rest of your life, or do something else. But now, today, with serverless technology and with the cloud and with backend, actually, you can take on this challenge. You can say, yeah, why not? I can do that. I can most probably do that. So we are going to talk about serverless. This is a Stack Overflow developer survey from last year that says that serverless is 75% of the respondents says they love serverless platform. And actually, I didn't show you the 2019 result, not because the numbers are significantly different, but just because they remove serverless as a platform in the survey, so they don't talk about serverless anymore. 75% serverless, 68% AWS, which is roughly the same for this year. So if you were one of these respondents, there is probably 3 out of 4 of you there, which are interested by the rest of this talk. But okay, let's talk about serverless. That's a good thing, but what is serverless? And serverless, it's not that. So serverless, it's not lack of server in your data center. Of course, somewhere in the cloud, somewhere in someone else's data center, there are servers, there is hardware, there is air conditioning, there is electricity, and all the things we hate to love, or we love to hate, with real server. Serverless means that you don't have to manage the server. It means we do manage the server for you. By managing the server, it's all the things I just mentioned, to provision a server, to buy a server, to install the hardware, to install the software. We do that for you. So no server to manage on your side, which allows your team to focus on the things that really matters, which is developing application and providing functionalities for your customer. Build your app or your service better than your competitor. Make a real difference for your customer. It's not because you are the king at installing Linux or Windows and automating that your app will be better. Installing Windows or Linux, everybody has to do that. If you are in healthcare, if you are in finance, in insurance, if you are a startup, everybody has to do that. At AWS, we call that the undifferentiated heavy lifting. I call that the plumbery, because that's the pipes, that's the things that everybody has to do, no matter what. Serverless also means that we do scale with usage. Scaling with usage means you can start really small and suddenly be super successful, which I wish you for all of you, like 10,000, 100,000, 1 million customers without changing anything in your infrastructure. If your application is correctly coded, if your architecture, your serverless architecture is correct, there is no change between a 10-user serverless architecture and a 1 million serverless architecture. We can scale for you automatically. You do not need to buy more hardware and to provision more software to support the load. We designed the systems to be highly available and fault tolerant. So most of our systems can work across multiple availability zones or sometimes across multiple regions. Of course, you have a bit of responsibility there as well. You decide to replicate the data or not, for example. And you only pay for what you use. And that's a very important point for serverless. If you are not using serverless, you are not paying anything. There is no upfront cost. There is no upfront commitment. You can just start to use it today, use it a little bit and pay just a little bit, or use it a lot tomorrow and pay a bit more. And serverless is not only compute, it's not only a CPU and memory, because today when we talk about serverless, most of you are probably thinking about functions, like function as a service, AWS Lambda, for example. But serverless, think about AWS services that are matching these four characteristics, this definition of serverless. Amazon S3 for file storage. Amazon S3 is 13 years old this year, 13 years old. And Amazon S3, it's serverless file storage. You don't have server to manage. You pay only for what you use. It's scaled with your usage. You can store 50 bytes of data or 50 petabytes of data or terabyte of data on S3, and you pay only for what you use. So S3, DynamoDB are serverless services, even if we don't use the word serverless in it. So don't limit yourself thinking about serverless as being something for compute, for code to execute. So compute is one of them. API is another category of serverless services. We have API gateways. We have AppSync. I'm going to talk a lot about AppSync during this talk. We have tools to support the developer workflow, tools to build your code, to test your code, to deploy your code into production. Look at AWS Code Pipeline, Code Commit, Code Build, which allows you to implement a continuous integration, continuous deployment pipeline in the cloud without server. And of course, database with DynamoDB, for example, the NoSQL fully managed database. So knowing that you have serverless, what obstacle are you facing? You're the front-end guy, you need to write that mobile app or that web app, and what's preventing you for using these? First thing, or one of the things that we hear a lot from our customers is this. You have more than 160 services on AWS. So the very first time you open the console, you are in front of that, and you scratch your head, and you say, OK, where should I start? We try to group these services by categories. So there are services for IoT, for mobile, for data migration, for database. There are some core services like virtual machines, the networking stuff. But where should you start? It would be nice if you have a tools that guide you a bit there, that takes some opinion, that takes some assumption about, OK, we are going to select that and that and that because we know these are the best practices for backend services to support a front-end application. The other problems that customers are telling us is that there is a lot of configuration. You just go to the console, and then you still need to configure the things to get some default that makes sense for your application. And once again, it would be nice to have a tool, an opinionated tool, tools that has some opinion, tools that force you a bit into a specific direction where some defaults are making sense for most of you, but of course with enough flexibility to change the default. So what we hear is that you need to be guided to know where to start, what product to use, and how to configure these services from scratch when you're starting a new application. And that's why we introduce AWS Amplify. Just a quick poll here. Also, let me check that you still hear me correctly. Who is using AWS Amplify? Just very few in the front. So I assume the rest is learning about AWS Amplify today. AWS Amplify, it's difficult to define in a very short one-sentence phrase, so I will do it in 2 or 3 phrases. It's a set of libraries. It's a set of frameworks. I don't like the word frameworks because it can be a bit everything, but it's a set of libraries that you can include inside your front-end application to make it easy to access to back-end cloud services. So it's a set of libraries that you can include in your front-end application, mobile or web application. It's also a command line tool. The command line tools allow you to provision back-end services. basis, using some preset default that I just talked about before. So you can add to your authentication. You can add to your application an API, GraphQL API or REST API, and just push that configuration to the cloud. Pushing means what? Amplify is not reinventing the wheel. Amplify will generate CloudFormation templates. If you don't know what is a CloudFormation template, it's a JSON file or a YAML file that allows you to describe your infrastructure in the cloud and to automatically generate that infrastructure for you. So Amplify generates the CloudFormation templates and deploy these CloudFormation templates for you in the cloud. So a CLI, a command line interface that you can use from Linux, from Mac, from Windows, and a set of libraries to include inside your mobile application or your front-end application. And we do support all major frameworks there. You see the logo of Vue, Ionic, Angular, React, and for mobile, of course, Android and iOS. Android both with Java and Kotlin, iOS both with Objective-C and Swift. So today, for the next half an hour that I have with you, I'm going to start from a React application. That's the hello world of React. So if you don't know React, don't worry, it's exactly the same principle. And then the tools I'm going to use are the same if you are using React, Angulars, or others. React has been designed by Facebook to build a web application and mobile application with React native. So let's start with that hello world. The first thing you need to do, it's Amplify init and Amplify push. I will do that right now because it takes 1 or 2 minutes to complete. So while I'm talking, it can initialize an environment for us. I'm using this IDE. This IDE, for those of you that do not know it, it's an IDE in the cloud. Yes, I have an AWS logo on my shirt, so everything I have is in the cloud. And it's called Cloud9. So it's an IDE running on a virtual machine on an EC2 instance. So let's Amplify init. What is the name of my project? Amplify nodes, a name for my environment. I can have multiple environment, dev, prod, test. What is my text editor? None of these. It's a JavaScript project written in React, source directory, build directory, script to build, script to start. And we want to use an AWS profile, and it's initializing a bucket for me in the cloud and the basic infrastructure that I need to deploy that project. In parallel, I can start my development environment and to start my application. And it should be a very, very basic application, which is available, a preview running application. Voila, that's my application in a browser, and I can have the same application running in a real browser tab, which allows me to debug my JavaScript a bit with more flexibility here. So I have my IDE, I have my app. Let's create a note-taking application. So you know one of these applications when you can type a note, the note will be stored somewhere. I can access it later. I can sort, I can search, I can delete my note. I'm not a graphic designer, so don't make fun of the graphical design of the screens you are going to see. I'm a developer, so I'm unable to create a nice user interface by definition. And that's my Amplify init. The first thing we want to do in a project is to add user authentication. I guess you have user authentication requirements in every single project, and doing that at scale and securely is not easy. Almost every week, now we read in the press that that company or that company leaked 100,000 passwords, 1 million passwords. It's almost a weekly news these days. So you don't want that to happen to you, being in the front headline news of the press. What about managing your identities in the cloud with a backend serverless service that allows you to manage identities at scale? It's called AWS Cognito, Amazon Cognito. And you can create that by going to the console. You can create an instance of Cognito and configure it and click in the console, or you can use Amplify to do it for you. So if I'm going back to my Amplify console, I can just type Amplify add authentication. Can you read on the screen from the back of the room? It's large enough? OK, good. I increase the size of the font. So you have the choice between default configuration with identity federation, or manual. Because it's a demo here, I will just choose the demo. I want to authenticate my user with a username. I want to collect an email. And that's pretty much it. Now I can say Amplify push. And Amplify push actually will create a Cognito, an AWS, an Amazon Cognito service for my application. So let me explain that in a bit more details, going back to my slides. Amplify add auth will ask you a few questions to collect your configuration requirement, will generate a configuration, and will create a service for you in the cloud. That's the easy part. Actually, on the back end, it's creating quite a lot of things. I will show you what it is creating in a minute. And of course, you need to modify the front end. There is no magic. If you want to add user authentication inside your application, you need to write a little bit of code as well. How to do that with React? You just import the authenticator component from Amplify. I told you that Amplify is a set of libraries. So you just import that component, and you wrap your application object with that function, with authenticator. And that's doing all the magic. It will trap the call. If the request is unauthenticated, it will display the authentication page. Then there is the whole authentication logic managed by Cognito. And when the user is authenticated, it will display the core of your application, the normal page of your application, with just one line of code. And of course, you can customize everything. So if you don't like the user interface, Cognito component inside Amplify has, I think, more than 25 methods. So you can do a fine-grained implementation of the login, logout, signing, sign-up flow, reset password, and all that. You can fully control that if you want to. But if you just want to quickly demo something on stage or for a prototype, it's one line of code. So what it is creating while I'm talking right now, it's creating a Cognito user pool. So it's a serverless, fully managed service to manage user and to implement common user flows like signing, sign up. So signing meaning to log in, sign up to create a new account, verify email address or verify phone number. By default, it's the email address by sending a code to that. It implements the change password flow. It can implement multi-factor authentication, so authentication with your username, password, and then a one-time code that you can retrieve from an app or send to your customer through SMS, through their phone. Cognito also supports identity federation, so you can have your customer authenticating as a well-known IDP, identity provider on the internet, a place where everybody has an identity, like Amazon Retail, login with Amazon, or Facebook, login with Facebook, Google, login with Google, or anything that supports OAuth, anything that supports OpenID Connect, or for enterprise, anything that supports Samuel. So you can do identity federation with Samuel, which means you can integrate with your Active Directory, with ADFS, for example, or any other systems. The graphical user interface that you see there is the one built in the React component of Amplify. As I said, you can customize it. You can build your own if you don't want that one, or you can customize that one if you just want to change a bit the style sheets. We do also provide a hosted GUI. So a hosted GUI means in the cloud, on the Cognito domain name, a GUI, and the user is redirected to that GUI where the user can authenticate or can create his username or be directed to log in with Google, log in with Facebook, log in with Amazon, and then come back to your application. The only change if you want to use federation, at code level, it's one line of code. Instead of wrapping your app object with the with authenticator, you can just call the federated signing method on the authentication object inside the Amplify framework. So one line of code to get login with Google, login with Facebook, login with Amazon. Of course, you need to configure the apps on Google, Facebook, or Amazon. That takes more time, actually, than writing the code to do the single sign-on. Let's see if my project has been deployed. I guess it has been deployed. Yes, it has been deployed. Let's change my app code already. OK. I don't want to type code in front of you, so I'm just using different branches. And here I have my new... oops, it's not right. Here I have my new app that has the with authenticator. So when I change the source code, in theory, the page should reload automatically. And because I'm not authenticated, the page has reloaded with the username and password screen. It's a new Cognito user pool, so I don't have an account. I need to create one. Let's create a password. an email. The email is important because by default it will go to present me a code there, and by default it doesn't check the phone number, so I can put anything there. But once again, you can change the default the way you like. So in a few minutes, I should receive a code on my email, and I will not wait for that mail to arrive because it might take a few minutes. So I will enter the code at the next step, at the next demo in this talk. Next, in your journey, in your developer journey, after you have added authentication, it's to add an API. You want your app to communicate with your backend. And adding an API might be quite challenging sometimes, especially if you have to manage the API yourself, if you're a full stack developer. Which API to use, REST API or GraphQL? GraphQL seems to receive a lot of traction and a lot of attention since 1 or 2 years now. This is the result of the State of JavaScript survey 2018, where you see that 62% of the responders says they would like to learn more about GraphQL, that's the second column, and 35% want to learn more about Apollo, which happens to be the open source implementation of a GraphQL server. So that's a quite large part of the JavaScript developer community. So what is GraphQL? GraphQL is a query language for your API. It's strongly typed. And I love that, because strongly typed means that we can generate tools that can do introspection and generate code for us. If you have already developed REST API, REST API is not typed, so it's very difficult to automatically generate code automatically as a client of your REST API. But you can do that with GraphQL. Maybe if you have white hairs, you remember something called SOAP and XML from last century or before. SOAP is also strongly typed. It has many disadvantages, but one of them is that you can generate code, client code for SOAP automatically, and I can find that again with GraphQL here. So this is an example of a type for my note-taking application. I will have an object called a note with an ID and a string, very basic. And from there, you can define what are the operations that you want to do on this type. So you can create queries, you can create mutation, and something really cool, you can create subscription. So a query, as the name implies, it's anything that will search for and retrieve your data. A mutation is anything that will change your data, create, update, or delete your data. And a subscription, it's something that does not exist in REST. It tells the server, please keep the connection open with me and notify me, inform me whenever something is changing on the server side. So imagine you have thousands, millions of mobile applications connected to your server. You can push notification on some specific events happening inside your backend. It's also a technology that has been created by Facebook, talking a lot about Facebook today, and they are using that in their mobile application. So if you are using the mobile or the website application of Facebook, you are using GraphQL. And when you see comments on posts that are popping up while you are using the application, it's a subscription that your application is actually doing towards the Facebook server. So the way it works for a developer, you create the query. So you say, for example, this is my get post query. I want the get post for an ID 1, and I want to retrieve as a result the ID, the title, the comment. Inside the comments, I want to get the content, and so on. You send that query to a GraphQL endpoint, a server somewhere available in the cloud, and the server will do whatever it is required to fetch the different data from different data sources. Some of them might come from a relational database. Some of them might come from EC2 instance and proprietary APIs. Some other can come from whatever, from a NoSQL DynamoDB database, for example. The GraphQL server will collect all these data and will return just what you need in one single round trip with the server. And that's the second biggest difference with REST. With REST, usually you query the server, and then you receive links inside your JSON, and if you want details on specific piece of data, your client needs to make several round trips to fetch the data with the server. With GraphQL, you can specify, the front-end developer, can specify what is the list of data I want, what do I need to build my screen, and with one single round trip with the server, you can fetch all the data that you need with graph, with dependencies. Very good, very well suited for graph type of data. Hence the name, GraphQL. So how can we add a GraphQL API to your application with Amplify? It's as easy as typing Amplify, add API. Then it would ask you the schema. And based on the schema, Amplify will generate all the queries, mutation, and everything, all the plumbery which is necessary to create your GraphQL API. A couple of questions it will ask. Let's see that in the demo. And let's start with that schema. Before going to the demo, just one more thing about that schema. That schema defines a node with an ID and a node, which is a string. But I would like to have a couple of authentication rules and authorization rules enforced on that schema. I would like me to be only able to access the nodes I created. I don't want to access the nodes you created, and you don't want me to access your node. So I want to restrict each user to its own node. You can do that with annotation. In GraphQL world, we call that a transformer. It's a add something. I call that an annotation because I'm coming from Java programming many years ago. Add auth means you add an authentication rules, an authorization rule on your data. And the add model is another transformer that Amplify will understand to generate a model for your schema. A model means a database being able to actually store your schema. So just by adding that little word, Amplify will create a DynamoDB database and will connect the GraphQL API with that database automatically. No lines of code to write, 0 line of code to write. Let's do that. Going back to Cloud9. Oh, by the way, I should have received my code now. Yes, my code is 047. It's not secret because it's only one usage, 665. And now I can authenticate as my user that I just created. That there is this banner on top where I can sign on and sign in. Once again, this is optional. You can define exactly the look and feel that you want. OK, going back to my IDE, and we are going to add an API for this. Let me first show you the user interface I would like to add a node and to see a couple of nodes. So let's take my phase2 code. So I will not go through every single line, but basically I'm adding a couple of components. One of them is to render a list of nodes from the database. And another one is to render an input to enter a new node on the screen. And I combine that with the header, the add node component, and the node list component. This is pure React. This is not related to AWS at all. Let's going back here, Amplify, add API. GraphQL or REST, Amplify support both. I choose for this demo to use GraphQL. The name, Amplify nodes. How should I authorize my user? Using just an API key, meaning anonymous access with just a key, or use my Cognito user pool. And of course, I just created a user pool. So I want only authenticated user with Amazon Cognito user pool to access that API. Do I have an annotated GraphQL schema? No, not yet. Do you want to be guided for the schema creation? Yes, please. What do you want? A single object with fields, one-to-many relationship, or objects with fine-grained access control? That's exactly what I want. I want fine-grained access control. Do I want to edit the schema? No. Yes, please. So it generates a file for me there, and it asks me to edit that file. I'm a bit lazy, so I will reuse a file that I have somewhere else, just to avoid to make any typo. Oops, that's the file I want to reuse. And that's the file I need to edit. Amplify, backend, API, schema. So let's have a look at that. That's exactly what you see on the slide, what you saw on the slide. It's a node, which is a model, which is limited by authorization to only allow the owner to access it with an ID and a string. So let's save that and come back to my editor. And now Amplify push. So Amplify push will ask me, do you want to create that API? Yes. Do you want to generate code? Yes, I want to generate code. JavaScript, TypeScript, Flow, let's say JavaScript. Do you want to generate all the possible permutation for your API? Create, update, delete? Yes. And now it's creating the API. So what does it take to create the API? We have a service at AWS that allows you to deploy GraphQL API. It's called AWS AppSync. So right now, what my Amplify push command is doing, it's creating an AppSync API. AppSync is the AWS service to host GraphQL API. And inside AppSync, there are 3 different parts that you need to know. One of them is the data source, is where AppSync will going to fetch will go and fetch the data. So it's creating a data source for me. And because I use the keyword model in my schema, it's also creating a DynamoDB database. DynamoDB is a fully managed NoSQL solution running on AWS. So it's creating a table in DynamoDB. It's creating AppSync. It tells AppSync to use that table on DynamoDB. It creates the schema, the basic schema. I have it. It's my type definition. But it creates all the operation to create, to search, to update, and to delete a node. So it's creating that API definition. And the things in AppSync, or the things in GraphQL in general, that links a schema, an API, with a data source, it's called a resolver. So the resolver is the piece of code that will allow the server, when the server receives a query to get all the nodes, for example, to actually go to the DynamoDB database. It's on the other side. The DynamoDB database, so that the GraphQL server can fetch the data from DynamoDB. So depending on the implementation of the GraphQL server you are using, it might be different technologies for the resolver. If you are using Apollo, for example, it's a JavaScript. You need to write JavaScript. For AppSync, we choose to use templates, and only templates, no code. Because what AppSync receives here, it's JSON. And what AppSync needs to give to DynamoDB, or REST, or whatever, it's also JSON. So we are from JSON to JSON there. There is really no need to have complex code. So we use an open source templating engine called Apache Velocity to transform the JSON that we receive there into JSON to pass there. And whatever DynamoDB will reply, we take that JSON back, we transform with one resolver, and we give it back to the client that is calling AppSync. And by the time I explain that, the API should be deployed. Yeah, the API has been deployed. And let's go here. And now, with the change I have in my source code, I have a new node. And I can type hello. I should type, let's be more local, hola, Madrid. And I should be able to store that. If I reload the page, the nodes are there. If we go behind the scene to see in DynamoDB, for example, we should see that a table has been created for me. If I look at all my tables, let's make that a bit bigger if you're in the back. This is the new table. And I have a table here with one new element saying Hola Madrid that has been created just right now, 7th of May at 1:30, it's GMT. It's not something I prepared before this. It's just a time zone difference. And so all the chain works from my front-end application to AppSync, which implements the React, which implements the GraphQL API, sorry, and to DynamoDB. Wow, that's already something. So we add user authentication, and we add support for a backend API with a NoSQL database. What about searching capabilities? If we want to add searching capabilities to our schema, the only thing we need to do is to add @searchable, like this searchable. So with just that keywords, GraphQL and Amplify will generate the GraphQL API for search and will create a server-side infrastructure for you. So you don't even need to add Amplify something. It's just changing the schema and do Amplify push. Beware if you are doing that, it's creating an Elasticsearch cluster in the backend. And today I'm talking about serverless. Elasticsearch is not serverless. It's a real EC2 instance or a couple of EC2 instances that you pay by the hour, even if you are not using it. So it's not falling into the definition of serverless that I gave at the beginning. So if you're trying that demo later at home or from work, be sure to shut down your cluster when you are not using it, because we don't want to charge you for something that you are not using. I will not do it, because it takes 15 minutes exactly to create, and I have 10 minutes left. But just to show you what it is building, if you just add that searchable keyword. So this is the situation where I left the previous demo. We have AppSync with the schema, the resolver, and the DynamoDB database. Just adding that little searchable keywords, it's creating an Elasticsearch cluster in the backend for you. First thing. Second thing, it's creating a Lambda function that will be activated every time you change something on DynamoDB. Remember the trigger from your father or grandfather relational database? That's the exact same idea. The Lambda function acts as a trigger for DynamoDB. Whenever something is changed in DynamoDB, the Lambda function is invoked. It will take the change from DynamoDB and inject that into the index of Elasticsearch. Then it's also creating a new data source, new resolver to talk to that data source, and one new API, a search node API. So just adding one single word in the schema. I have another application which is deployed. That one I deployed before this session to ensure that I can show you the result. And it's running on a different user pool with a different user database, so that's why there is much more nodes there. I can add a node, hello Madrid. I did that demo in a few cities already. And you can search. You can search for Oslo, for example. And searching for Oslo called the new search operation that has been defined by Amplify on GraphQL. GraphQL AppSync is calling Elasticsearch cluster to get the result and return the result back to the user interface, to the front end. I told you that the GUI is not great. If you want to go back to the list, you need to cancel this and search again. But basically, in 15 minutes, you can add enterprise-level search capabilities to your application. Last step is to deploy your app. Deploying a React or Angular app, it's just an HTML and JavaScript. There is no processing on the server side, so you don't really need to have EC2 instance and memory and CPU on the server side. What's better to host single-page web application than Amazon S3? Because Amazon S3 has an API to retrieve objects, files with HTTP, HTTPS, and your browser on the other side is speaking HTTP, HTTPS, so it looks like a perfect match. And you don't have to scale it, you don't have to carry about high availability, because we design Amazon S3 to be highly available. So if you want to host your app on S3, you can just add Amplify, add hosting, and publish. Let's do that. It takes 2 or 3 minutes to complete. Back to my code here. Amplify, add hosting. It will ask me if I want dev or prod. I will explain you the difference in a minute. I just choose dev here. The name of the bucket, the name of the index document, error document, and that's it. Amplify push and Amplify publish. Push will create the infrastructure for me. It will create the S3 bucket with all the required security. And publish will actually compile, actually it's a real compilation, compile my React application and publish, copy these files to Amazon S3 so that it can be served over there. So the whole process will take 1 or 2 minutes, and I will show you what it is creating while it's doing that. So in dev mode, it's creating an Amazon S3 bucket. It will configure that S3 bucket to be read-only, and every single individual file will receive read access. So you cannot accidentally leak a file on that bucket. It will also configure that bucket to do web hosting. That's a parameter in the Amazon S3 console, so that the bucket will start to receive regular HTTP GET requests, not anything using the S3 API, regular HTTP GET requests request and to start to serve file, like the index.html when it receives a get for slash, for example. If you choose the prod configuration, production, it adds on top of that a CloudFront distribution. CloudFront, it's our serverless service for content delivery. So basically, it's a set of network cache at the edge of the network that allows you to cache your static web page or your media content close to your customer. We have more than 160 different locations across the globe, including one here. So if I'm accessing the URL of CloudFront from here, my request will go to the Madrid cache. The Madrid cache will fetch from the origin, which is Amazon S3, and keep a copy in the cache for other customers in the same geographic area. By the time I explain that, the deployment should be finished. It is, and it gives us the address that we can use. Open. Hello. Okay, let's copy it. My console is so large, the fonts are so large that not everything is displayed there. And so where can I get access this? I can go to that file that has been generated for me and find the deployment address there. And that's the full URL that has been created for me. So that website is a copy of the one running in Cloud9 right now, the one I was using for development, because it's a different domain name. The cookies, the authentication cookies are not working, so I need to re-authenticate again on that domain. And it's hitting the same database, so I should find my Hola Madrid that I created inside my development environment before. So I have a fully running hosted application, hosted in the cloud with a GraphQL API, with a NoSQL database, and with strong user authentication. I have still 3 minutes to share a couple of advanced topics if you want to go further with Amplify. First of all, you have to know that Amplify supports the developer workflow. So if you are working with Git and multiple branch, like it is a best practice to do if you are working with Git, each developer checkouts, create its own branch, do experiment on your own branch, and then you merge back your own branch with the master branch or the trunk. If you do that, you need, of course, your own dedicated cloud environment so that you can experiment with that. You have your own Cognito user pool, you have your own API so that you can experiment without breaking the chain from the main development branch. So Amplify understand the branch. You just type Amplify checkout and the name of the environment, and then Amplify add and the name of the environment, and it will create separate cloud infrastructure for each branch that you have in your Git. Very important black belt tip if you are developing in teams, and I guess most of you are developing in teams. The second black belt tip I would like to share is Amplify Console. Amplify Console is something that we launched at reInvent, the Las Vegas customer conference last year in November. It's a fully hosted continuous integration and continuous deployment pipeline for your Amplify application. So the idea of Amplify Console is that it connects to one of your source code repository. It might be AWS Code Commit, the managed service from AWS, the managed Git repository from AWS, but it also might be Bitbucket or GitHub or GitLab, whatever you choose. It will detect change over there, so whenever you commit code on that repository, it will initiate a full build of your project, so it automatically recognizes an Angular project or React project and generates the build for you. And it deploys the result of the build to your Amazon S3 bucket. And you can even configure that to use your own domain name, for example. I'm using that for my personal website, stormacq.com. It's fully automated. It's not React, it's another technology. It's Jekyll I'm using there, but it connects from the repository, build my website, and deploy that to an Amazon S3 bucket. So if you're using Amplify and want to easily configure continuous integration and continuous deployment, have a look at the Amplify console. So, just to recap, what we do in the last 45 minutes. I introduce you AWS Amplify, which is both a command line to help you to provision backend server in the cloud, and a set of libraries that allows you to easily interact with this service in the cloud. We start with a hello world type of React application. We add user signing, sign up, change password, and identity federation with Amazon Cognito. We add an API, a GraphQL API with AWS AppSync and Amazon DynamoDB to persist the data. We add a search API with Elasticsearch. I cheat a bit on that one because I didn't deploy it in front of you just because of time. It takes 15 minutes to create the Elasticsearch cluster. And then we finish by hosting that application on an Amazon S3 bucket. If you want to experiment that by yourself, just go to my GitHub, github/Amplify React workshop. You will find all the source code of the different phase, and you can see how that demo is built, and you can experiment that demo at home on your personal account. Once again, if you do that, beware of the Elasticsearch cluster. Be sure to kill that cluster so that you are not charged for service that you are not going to use. And that's it. I hope I inspire you to discover a new technology and to try new things like GraphQL, like Amplify. So now it's your turn. Go home, go back at the office and build on this technology and build amazing application that will surprise us. I love to hear your stories about the application that you are building and deploying on AWS. Give me feedback on my Twitter, Sebsto, S-E-B-S-T-O. The slides should be ready in 1 minute. If you go on Twitter in 1 or 2 minutes, you will see the slide deck that I presented today, and you can download the PDF for you. Muchas gracias.